Question 4 steps it up slightly, but it gives you a nice hint in part A. The lengths of two sides of it in a triangle are 4 centimetres and 5 centimetres. Let theta be the angle between the two given sides. First thing I'm doing, therefore, is drawing a diagram. No idea what my triangle looks like. Doesn't really matter. It just matters that I have some visual idea of what's happening. The triangle has an area of 5 root 15 over 2 centimetres squared. Show that sine theta is root 15 over 4. So I'm immediately thinking, well, the area of a non-right angle triangle is equal to a half AB sine C, or in this case, a half times 4 times 5 times sine theta. And I know that's equal to 5 root 15 over 2. So a half times 4 times 5 is just 10, so 10 sine theta is equal to 5 root 15 over 2. I can divide both sides by 5 and then again by 2. Sine theta is root 15 over 4. And because this is a show that question, I'm making absolutely clear to illustrate that I know exactly what I'm doing from each step. Part B then, find the two possible values for the length of the third side. Let's call that third side x. So I have one angle and 3 sides, one of which I want to know, so I can use my cosine rule. So I know that x squared is equal to 4 squared plus 5 squared minus 2 times 4 times 5 times cosine theta. I don't know what cosine theta is, but I do know what sine theta is, so I can use my Pythagorean identity. That is cosine squared theta is equal to 1 minus sine squared theta. So cosine squared theta is 1 minus 15 over 16, which is 1 over 16. Square rooting both sides gives me cosine theta is equal to a quarter or minus a quarter. And I've got my little hint there, 2 possible values for the third side. So I substitute that into my equation. X squared is 4 squared, that's 16 plus 5 squared, 25, minus 2 times 4 times 5, that's 40, times a quarter, which is x squared is equal to 16 plus 25 is 41, minus 10, 31. Or I could have x squared is equal to 16 plus 25 minus 40 times minus a quarter, and I'll make that minus clearer, and that's 16 clearer, which is 41 plus 10, 51. And therefore, x is equal to either root 31 or root 51. And I can neglect minus root 31 and minus root 51 because x is a length. It must therefore be greater than 0. So I have my solutions. Looking at the mark scheme for this question, for part A, you get 1 mark either for working out the height of your triangle. I don't really know why you'd bother doing that, or just A equals a half AB sine C, and then simplifying using basic algebra. It's only worth 1 mark. It's really just there to help you and give you a hint for part B. For part B, you get 1 mark for using your cosine rule, 1 mark for rearranging that algebraically, and using your Pythagorean identity to find cosine theta. Then you get 2 more marks, 1 for each solution of for cosine theta, and then you get another 2 marks for substituting back into your cosine rule and evaluating correctly. And that's 7 marks sorted.